Okay, so this is another one of those little sciencey little quirks that I find interesting that I don't hear discussed very often when the topic is discussed. I'm not saying there aren't solutions and so forth. I'm just saying it's one of those little quirky things that I don't hear discussed as often. And so the general topic is about time dilation in relativity as an object gets closer and closer to a fraction of the speed of light. There's this mentioning of its time being dilated in relation or relative to something else that's not moving at that same speed. Because in relativity, time is relative. It's not an absolute in all reference frames. Um, and one common experiment that was done, what and is referenced, is atomic clocks, which are very precise and so forth. And they have one on the ground that's synchronized, and they take another one that's synchronized with that first one, and they put it up in orbit, and it's going around at a very fast speed. And after some period of time, they then bring them back together, and they check them, and they see that there's now a difference. And that difference in the framework of relativity is explained by the time dilation effect of the one that was going around in orbit was traveling fast enough that it experienced a small amount of time dilation. So the assumption that they're making is that the rate of change of the atomic processes in the atomic clock that cause it to have its cycles and so forth, they're assuming the rate of change has stayed the same, but it's the time dilation from that speed that has happened, not a change in the actual rate of change itself. So for instance, if you have so many cycles per second of the clock, then that cycles per second still is the same. It's just that it experienced fewer seconds of time, therefore time dilation, compared to or relative to the slower moving object. Now, that assumption about the rate of change is constant. It was the time dilation that happened is a subjective thing, and my own personal two bits is that I think the rate of change of the atomic process as it gets up closer to that speed is a little more preferred for me than saying that time itself changed, but that's a separate issue. So part of that is not discussed is that rate of change versus rate of time. But the second part, the bigger part that I find interesting, is it's not just the clock cycles. It's not just the twin in orbit or something like that. But it's the rate of travel, the velocity of the object itself is a function of the amount of its passage through time. If I have some electron or something that's accelerated for a particle collider or whatever, that's accelerated up to some significant fraction of the speed of light, it's going at that speed. It has a certain amount of meters per second. Okay, so if it's going so many meters per second, it still needs second to travel so many meters. Even if it were light itself, as crazy fast as light is, so many meters per second, with half a second of time, it only travels half that distance. With 1/10 a second of time, it only travels 1/10 that distance, or less, depending on the medium and so forth, blah, blah, blah. But whatever that velocity is, it's still a unit per its rate of time, which means that if time dilation reached the point that it went to zero, time stopped, then no matter what your velocity was, you could be going the speed of light as far as your velocity or half the speed of light or whatever, you still wouldn't physically move forward because no time for you is passing, even if your velocity is still that big. It's kind of like if you think of like, say a movie. In the movie, some car or bullet is flying by the screen at 80 miles an hour, 800 miles an hour, or whatever. If you pause the movie, you stopped the rate of time. That bullet in the frame of reference, the point of view of the movie, is still at its velocity. It's just that it needs time in order to move a distance. Or that car, in the frame of reference or point of view of the movie, it's moving at 80 miles an hour or whatever. But if I slow down the rate at which I'm playing the movie, then it seems to me that it's moving slower, because there's a difference in my experience of rate of time, many seconds. How quickly do I experience a second versus it? So if I'm experiencing 10 seconds for every 1 second it experiences, then it would look to me as though that 80 miles per hour was only going 8 miles an hour. It might still be actually going 80 miles an hour in its reference frame. And if, as far as conservation of momentum and conservation of energy, kinetic energy, and all that stuff, it's still going 80 miles an hour. But if from my reference frame, if it's going 1/10 of the rate of time as time dilation, then it would seem to be traveling 1/10 that speed to me. And not just the car, but the electron going 3/4 the speed of light or 90% the speed of light, whatever you want to do. The velocity is not just the oscillations of an atomic clock or decay of a radioactive isotope or anything like that. It's the velocity component itself is a function of time as well. So that's another aspect of that that's not often discussed. I find it interesting, so I thought I'd bring it up. And there you go. Now you know.